Okay, so let's finish up that last problem. And when we're looking at this one, we've got the probability of Jupiter wannabe that was a senior. So on this one, we'd be doing, our condition is a Jupiter wannabe. That's our condition. So it's the probability of senior given Jupiter wannabe. And so it's the probability of Jupiter and senior divided by the probability of Jupiter. So the probability of Jupiter and senior right here we found was 0.144 divided by the probability of Jupiter. And that's not one we found. So the probability of Jupiter would be the sum of the probability of, oh yeah, we do. Probability of Jupiter is just the 0.36. And so this gives us 0.400. Okay, now, you're really going to like the two-way tables because it makes some of this other much easier to find. If we look at the probability of senior and Jupiter, well, we've found that the probability of senior and Jupiter, 0.144. And the total here for Jupiter was 0.360. So the probability that they were Jupiter and not a senior, Jupiter and not a senior would be the 0.36 times the 0.6, and that would give us 0.16. Or we could just subtract here because they're going to add up. Okay, the probability that they were a senior and did not want to go to Jupiter is 0.192. This is 0.448, and this is 0.640. The probability that they were a senior was 0.336, and we calculated that just a minute ago. And so what would that leave here? 0.664, because it has to add up to 1. So this is our two-way percent table. It's our relative frequency table, and yours has that over to the side. You just can't see it on mine. Okay, one way we could have gotten some of this information was to do the probability of Jupiter, and in this case it would be the probability of not Jupiter, times the probability of senior given Jupiter. Okay, so here, this is the probability of Jupiter, senior given Jupiter. That gives us the 0.36 times the 0.4, and we used that information earlier, 0.144. Okay? Senior and Jupiter. All right, and then this would have been the 0.36 times the 0.6 for this, 0.36 times the 0.6. That's where we got the 0.126 from. No, 0.216. All right, down here, this would be not Jupiter senior, and that would be 0.64 times the 0.3, and that gave us the 0.192. That's where this number comes from. And then the last one would be the 0.64 times the 0.7, 0.64 times the 0.7, and this gives us 0.448, and that's where this number comes from. And then we add them all up. Add them all up, and did they work? Yes, they did. So if we did have 500 students, how would we find the ones that would fall in each one of these? So we would do the 0.144 times the 500, and that would give us 72 students here. And then the 0.192 times the 500 would give us 96 students here. The 0.336 times the 500 would give us 168. And then this would give us 108, 180, 224, and 320. And this is 332. So not only could we fill these out, if I gave you this to begin with, you could go back and answer all the other questions. So when we can go one way or the other with our two-way charts, and then we can use our two-way charts to answer questions. And if you look at your homework, and I'm getting to it, it is the back of this page. You're going to create your chart, and then you might find it easiest to answer questions from your chart. So tonight you're doing the back side, and then tomorrow we'll talk about independence or dependence given these charts. So tonight, do your best with the back of the worksheet, and we'll talk about it on Monday. Thanks.